If you think deep space is just empty, cold, nothing, don't subscribe. But if you want the strangest thing Voyager 2 may have been carrying for decades without anyone noticing, subscribe now. Because this story is not about a new rocket launch. It's about an old machine that refuses to die, and a new way of looking at its past that is making people argue all over again. Voyager 2 launched in 1977. It was built for a mission that was supposed to be short. Instead, it turned into one of the longest-running deep space journeys ever. It flew past the giant planets like a fast-moving flashlight, grabbing what it could in a few hours, then racing on into the dark. And if you're picturing Voyager like a big, shiny spaceship, reset that image. Voyager is more like a tough little camping radio tied to a metal frame. It is not powerful, it is not fast, it is not modern, it is just stubborn. It speaks to Earth with a weak signal that has to cross an ocean of space. The Deep Space Network listens with huge radio dishes, and teams at NASA's Jet Propulsion Laboratory in California keep the whole thing alive by making hard choices. Turn off this instrument so that one can survive. Reduce power here so the transmitter can keep whispering a little longer. It's like keeping an old generator running in a storm with duct tape and patience. Now, here's the twist that makes this story worth your time. Voyager 2's data is not one clean movie. It's a pile of signals. Images, yes, but also magnetic field readings, plasma measurements, particle counts, timing logs. Some parts are clean, some parts are messy. Some parts are so noisy that for years, the easiest label was the simple label, noise. That word is the graveyard of mysteries. Not because scientists are lazy, because time is limited. People focus on what they can confirm, publish, and defend. But now we have a different weapon. We can mine old data with modern tools. Better models, better computers, better filters. And yes, sometimes machine learning, the kind of pattern finding that can scan a mountain of messy measurements and point at the tiny corner that refuses to behave like random. So the rumor that's been spreading is simple and explosive. An AI recheck of archived Voyager 2 material found an odd structure near the Uranus encounter, something that looked too symmetric to be written off as static. People describe it like a ring, like a donut shape, like a faint design in the magnetic noise that feels precise. Then the rumor gets darker. They say the strange pattern lines up with a moment when the spacecraft's instruments recorded a brief voltage irregularity, like a synchronized hiccup. And beyond that, they point to strange plasma wave behavior later in the mission, a low, rhythmic pattern that sounds less like random space weather and more like a steady knocking, slow and patient. Now, stop right there, because if you're expecting me to scream aliens, I'm not doing that. Here's the honest rule for a NASA-style story. If a claim is huge, the proof has to be boring. Meaning, before you call anything contact, you have to eliminate the three things that fake contact better than anything else: spacecraft quirks, processing artifacts, and nature making geometry, because nature loves geometry. And humans love to mistake geometry for intention. So let's walk this like a real investigation, but keep it human. Think of the Voyager archive like a dusty room full of old videotapes. Some of them are clear. Some of them look like snow. And for decades, people assumed the snowy ones were worthless. Now you bring in modern restoration. You clean it up. You stabilize it. You reduce the noise. And suddenly the snow isn't just snow. There's a shape behind it. That's the feeling that started this whole wildfire. But what could that shape actually be in a way that makes sense? Start with Uranus. Uranus is a troublemaker planet. It spins on its side. Its magnetic field is weird compared to Earth. It's tilted and off-center, which means its magnetosphere can behave like a lopsided, shifting bubble. Voyager 2 arrived in 1986 and gave us our only close-up pass, one moment. And it turns out that moment may have been unusually extreme. Scientists have revisited that data set again and again because there is no second flyby to compare it to. And in recent years, teams working with Voyager 2's Uranus measurements have argued that the spacecraft caught Uranus in an abnormal, compressed magnetosphere state, something that may happen only a small fraction of the time. That alone is a huge deal, because it means some of the old Uranus mysteries might not be Uranus is broken, but we watched Uranus on a bad weather day. So picture the scene. Voyager 2 is flying behind Uranus through its magnetotail. The magnetotail is like the long stretched wake of a planet's magnetic field, pulled out by the solar wind like a flag. And inside that tail, you can get big magnetic structures, plasmoids. Think of them like giant loop-like blobs of magnetic field and plasma that can pinch off and travel down the tail. That part is not science fiction. That's real magnetosphere behavior. Now imagine you have high-resolution magnetic data from that moment, and you reanalyze it with modern processing. You might pull out a loop-like signature, a donut-like geometry, that was always there but hard to see in the messy raw. That could look eerie if you're expecting a clean, random mess. Instead, you see order. So the first grounded explanation for the hidden image is not aliens, it's magnetospheric physics. A natural structure, captured at the right moment, that looks engineered because it's symmetric and layered. But then why did people freak out? Because the claim is that it doesn't look like typical natural symmetry. They say it looks too precise, too clean, too intentional. Okay, so we test the claim. Here are the three main ways you can accidentally create a fake engineered shape from old spacecraft data. 1. Instrument fingerprint. Voyager instruments have quirks. Sensors have noise patterns. Old compression and transmission can imprint repeating textures. If you enhance too aggressively, you can sharpen those textures into shapes. It's like turning up the contrast on a grainy photo until the grain starts looking like symbols. 2. Spacecraft behavior. Voyager is not a rock. It spins. It maintains antenna pointing. It does small control actions. It heats and cools. It switches modes. Those cycles can create rhythms and patterns in the data. If you don't subtract them correctly, you might think you discovered an external signal when you actually discover the spacecraft's heartbeat. 3. Processing bias. If you run data through one specific pipeline with one specific setting, you can accidentally reveal a pattern that only exists in that one setting. It's a mirage created by your method. So what decides whether the hidden image is real? The kill test. A fake pattern hates sunlight. It disappears when you shine a second flashlight on it. A real pattern survives, meaning independent teams using independent pipelines should be able to reproduce it. Different code, different settings, same result. If the shape only appears when one person uses one magic recipe, it's probably not a discovery. It's probably a trick. Now, here's where the story gets heavy, because even if the pattern is natural, it still matters. If modern analysis reveals a real plasmoid structure in Uranus's magnetotail that was hidden inside what people called noise, then we didn't invent a mystery. We uncovered one. And that forces a scary thought. How much more is buried in the archive? Not aliens, not monsters. Real physics we didn't understand well enough to notice the first time. And that's where the story turns from Uranus data is weird into deep space is not what we think. Because Voyager 2 didn't stop at Uranus. It kept going, past Neptune, out to the edge of the sun's influence, and beyond. In late 2018, Voyager 2 crossed the Heliopause, the boundary where the solar wind fades and the interstellar medium becomes the main environment. That boundary is not a clean wall. It's not a gate. It's more like a shifting shoreline with layers and ripples and sudden changes. Voyager 1 crossed earlier in a different place, and the two spacecraft did not experience the boundary in exactly the same way. That alone tells you something important. Interstellar space is not uniform. It has structure. Now, let's talk about plasma waves without making it sound like wizard talk. Plasma is charged gas. In space, plasma carries waves, ripples, vibrations. Voyager has instruments that can detect those plasma wave patterns. A lot of the long-term plasma wave work tied to Voyager has been led by specialists who spent decades turning faint signals into real measurements. So when people say Voyager heard a hum, the grounded version is this. Voyager's instruments detect wave activity in the plasma around it, and those patterns can sometimes show coherence. The internet version is, it's a message. We don't jump there, we build. If you want to argue that a pattern is more than random, you look for three traits: consistency, coherence, independence. Consistency means the timing stays stable. Coherence means it has a clean structure. Independence means it shows up across more than one kind of measurement, like plasma waves, lining up with magnetic field changes in a way that makes physical sense. Here is the nightmare that still doesn't require aliens. Voyager could fly through a structured region of plasma in interstellar space, a magnetic bubble, a boundary layer, a shock, a density structure. Not an object with bolts, just a region with order. If Voyager crosses it, the data might look like a slow, rhythmic knocking. Not because someone is knocking, because Voyager is moving through a patterned environment, like driving through rain bands in a storm. The rain comes in pulses. You feel rhythm, but nobody is sending you a beat. It's the structure of the storm. So how do you test whether the pulse is real, environment, or spacecraft behavior? You compare it to spacecraft cycles. If the rhythm matches known power or instrument cycles, it's probably internal. You compare it to orientation. If the pattern changes when the spacecraft orientation changes in a way that matches thermal shading or antenna pointing, it's likely spacecraft. You compare it between Voyager 1 and Voyager 2. If both saw similar features under similar conditions, it's likely environmental. And you look for correlation. If plasma pulses line up with magnetic shifts in a physically meaningful way, it becomes harder to dismiss. Now, here's where the story gets spooky again, because people want the spooky version. They say the AI that reprocessed the data reacted, that it halted, flagged it, refused to proceed, like it sensed something. Let's keep that clean. AI can halt for 100 boring reasons: memory limits, confidence thresholds, safety filters, model uncertainty. It can flag something as critical because it is an outlier, not because it is alive. But even that boring explanation still leaves the emotional truth. The algorithm kept pointing at the same corner of the data, like a dog staring at a dark hallway. The dog isn't proving there's a ghost. The dog is proving there's something unusual enough to keep staring. Now, add one more ingredient that makes people lean in: culture. People love the idea that ancient star maps predicted something like this: Babylonian, Aboriginal, patterns echoed in myth, a snake in the sky, a ring, a cosmic eye. Here's how you handle that without turning the whole video into a fantasy channel. You treat it as a mirror, not as proof. Human beings look at the sky and create symbols. Sometimes those symbols repeat across cultures because humans share the same brain and the same stars. A ring is a ring everywhere. A spiral is a spiral everywhere. That doesn't mean people saw an alien machine, but it does mean something else. The sky has always been our first screen, and humans have always tried to read it. So when a modern tool pulls a geometric pattern out of a deep space archive, it doesn't just trigger science questions. It triggers human questions. What if we have been too confident calling things noise? What if deep space has structure we don't understand? What if random is just a word we use when we're tired? Now, we are ready to define the real tension of this entire story. And it's not contact. The tension is evidence. What would count as a true proximity event? The kind of event that would make even skeptical engineers stop talking for a second. Not a blurry image, not a pretty shape, not a spooky rumor. A proximity event would leave a fingerprint across multiple systems at the same time. For example, a sudden, synchronized disturbance in the magnetic field, plus a change in plasma wave activity, plus a temporary instrument irregularity, all aligned in a tight time window, not explainable by spacecraft cycles. If you had that, then you wouldn't have proof of aliens. You would have proof that Voyager encountered something it did not expect. Something physical in the environment. Something real enough to touch multiple sensors. Now, here's the open loop that matters. The Uranus dataset already contains known magnetotail events and plasmoid-like structures that modern researchers can analyze with much more clarity than ever before. The Interstellar dataset contains plasma patterns that still raise questions about how structured the boundary and near-boundary environment really is. And Voyager 2 is still out there, still alive, still whispering, while its archive keeps getting mined like an old cave that never stops producing surprises. So the next question is not, did Voyager make contact? The next question is sharper and more dangerous. If there is a pattern that survives the kill tests, what exactly does it imply? And what is the single strongest piece of evidence, hidden in plain sight, that would force a serious public recheck of everything we think we know about what Voyager 2 passed through? Because if that evidence exists, then the scariest line in this whole story becomes true. It's possible the first sign of something unknown was recorded decades ago, and we only notice now because we finally learned how to look. So let's keep going, like we're in the control room, not in a movie. If a weird pattern shows up in old Voyager 2 data, the first job is not to celebrate. The first job is to attack it hard, because if it's real, it will survive the attack. And if it's not real, it will fall apart fast. Start with the simplest question that embarrasses the most people. Did the pattern exist before the cleanup? Because a lot of hidden images are born the same way. You take messy data, you clean it, you sharpen it, you smooth it, you stack it, you stretch contrast, you remove noise, and suddenly you get something that looks meaningful. But the danger is, you can also create meaning by accident. So, if you want this to feel like real NASA work, you do this in your story. You tell the viewer that the pattern has to pass 3 checks. First check, raw check. Not raw as in ugly, unreadable, but raw as in before the fancy tricks. Does the structure leave even a faint fingerprint without heavy enhancement, even if it's weak, even if you need to know where to look? If it's completely invisible until you use one specific magical filter, that's a bad sign. Second check, cross-check. Does the same timing window show something odd in more than one instrument? Because a real event in space tends to touch multiple sensors. A fake event usually lives inside one sensor or one method. Third check, reproduction. Can 2 separate teams run different software and still pull out the same shape from the same time window? If it survives those 3, you don't declare contact. But you do say something serious. You say, this is not random noise. Now, let's put the viewer right into the Uranus moment, because that's where your summary lives. Voyager 2 is closing in on Uranus. This is 1986, and it's moving so fast that the whole encounter is basically one long blink. Uranus fills the instruments, then it's gone. No second chance. Uranus is already weird before Voyager even arrives. It's tipped on its side like it got shoved in a cosmic fight. Its magnetic field is not neatly lined up the way you'd expect if you learned magnetism from Earth. It's tilted. It's off-center. It creates a magnetosphere that is lopsided, twisted, and unpredictable. Now, imagine Voyager sliding through the magnetotail, the long stretched wake of magnetic field behind the planet. That tail can store energy, and when it releases energy, it can form huge magnetic structures that pinch off and shoot down the tail. People call these plasmoids. It sounds like a video game word, but the idea is simple. A plasmoid is like a blob of organized magnetic structure carrying plasma with it, like a bubble breaking free. If Voyager passed near a plasmoid event, the magnetometer would not just see random wobble. It could see a structure change, a loop-like shape, a pattern that looks like a ring because the field lines are doing something ring-like. And this is where the hidden image claim can be told in a way that stays believable. You can say, the AI didn't invent the shape, it simply made it visible, like cleaning a foggy window. The thing outside was always there. You just couldn't see it well. Now add the extra detail from your summary that makes it feel like more than just a pretty plasma blob. The synchronized voltage irregularity. In your story, it's logged as a brief moment where multiple readings show a tiny electrical disturbance at the same time. Maybe the sensors spike. Maybe the voltage shifts. Maybe the timing looks weird. This is the point where viewers think, okay, something touched the spacecraft. but we still stay honest. A voltage irregularity can be caused by external environment, yes, but it can also be caused by the spacecraft itself. Cold, radiation, aging electronics, instrument switching, a sudden load on the power system. So again, the kill test matters. Does the voltage irregularity line up with a known spacecraft action? If it does, it's probably internal. If it doesn't, and it lines up with a strong external magnetic disturbance, then it becomes more interesting. Because that would imply an environment event strong enough to affect both space physics readings and electronics behavior in the same window. Now pause for a second and let the viewer feel how weird that is. Voyager 2 is not a modern phone with a protective case and a million safety features. It's a tough little machine, but it's not invincible. If it passed through something unusual near Uranus and recorded a structured signature plus a systems hiccup, that doesn't automatically mean a highly advanced object. But it does mean this: Voyager was not alone in empty space. It was inside a living environment, a planet's magnetic world. And that world can do things we still don't fully predict. Now we shift to the second half of your summary. And this is where the story becomes more eerie, because it moves from one planet to the deep dark itself. Interstellar space. Voyager 2 crossed the Heliopause and entered the interstellar medium. It's like leaving a campfire bubble and stepping into the cold woods. The sun's influence weakens, the particles change, the magnetic field environment changes. And here's the core idea that keeps your story tense for a long time without needing aliens. The farther Voyager goes, the more we realize random is sometimes just unmapped. When people say interstellar space should be quiet and uniform, they're basically guessing based on small amounts of data. We do not have a fleet out there. We have two old probes, Voyager 1 and Voyager 2, moving through different regions at different times. That's not a full survey. That's two needles in a cosmic ocean. So if Voyager 2 measures plasma waves that show a rhythm, the first reaction should be curiosity, not panic. Because plasma can hum for natural reasons. Shocks can ring like bells. Density structures can produce repeating wave patterns. Magnetic boundaries can ripple. That's why the plasma wave instrument matters. It's basically one of the few ways we can listen to what the environment is doing, even when we can't see anything. A lot of this plasma wave work has been driven by long-running science teams, like the University of Iowa group, that help translate those faint wave signatures into real space physics. When people like that say, this pattern is interesting, they don't mean aliens. They mean our models are incomplete. Now here's where you make it relatable without making it silly. Tell the viewer to imagine driving at night through a foggy area with streetlights. Sometimes the lights look like they're pulsing. You feel rhythm, but it's not the lights sending you a message. It's you moving through layered fog, and your speed, and your distance, and your angle. Interstellar space can be like that. The rhythm could be the environment, or the rhythm could be the spacecraft, or the rhythm could be our processing. So we test it. You do the boring checks again. Does the pulse match any known spacecraft cycle? Power management cycles, instrument duty cycles, antenna pointing routines, thermal cycles. Does the pulse change when the spacecraft attitude changes? If the spacecraft turns slightly and the pulse changes in a way that matches orientation, that's suspicious for internal behavior. Does Voyager 1 see anything similar? Not necessarily at the same time, but in similar boundary regions. If both spacecraft have similar signatures, it argues for environmental structure. Does the pulse line up with other sensors? If plasma wave patterns coincide with magnetic field changes, it becomes more convincing that the environment is doing something structured. And now we address the AI halted itself due to a cognitive hazard thing from your summary. Here's how to say it without sounding like you're writing a fantasy novel. You say, the analysis flagged the segment as extremely unusual, not because the AI felt fear, because the data behaved like an outlier. Outliers are what algorithms are designed to catch. If a segment is too structured compared to the background, it gets flagged. Sometimes a system will stop processing if it hits a threshold for uncertainty or risk of producing false results. So you frame it like this: the AI didn't panic. The humans did, because the tool kept pointing at the same section like it mattered. Now bring back the human tension of the mission itself, because Voyager 2 is not sitting in a lab. It's out there right now, and it's old. The Jet Propulsion Laboratory has to manage it with care. The Deep Space Network has to catch a faint signal. Commands take hours to reach it. The data trickles back slowly, and every year, power gets tighter. So you build a line that hits like a stone. Even if the archive contains the biggest clue, we can't go back and take a better photo. We can't turn Voyager around and say, show us again. All we can do is squeeze the archive harder and listen more carefully to what the surviving instruments can still tell us. That's a perfect pressure cooker for your story because it means every weird detail matters. Now we bring in your cultural layer, the anthropologist and ancient star maps, but we do it in a way that stays smart. We say this: humans have always looked up and drawn shapes, spirals, rings, eyes, serpents, ladders in the sky, Babylonian sky records, Aboriginal sky stories, different languages, same stars, same human brain that loves patterns. So when someone sees a geometric ring-like signature in Voyager data and says it resembles ancient sky geometry, that is not proof of contact, but it is a powerful reminder of something real. We have been trying to read the sky since before we had telescopes. So modern tools pulling structure out of old deep space data feels like the same ancient instinct, just upgraded. Now the story needs a new anchor, something concrete, not aliens, not vibes. What would contact look like in data if it happened with no camera footage, no dramatic close-up shot, nothing you could post as a clear picture? This is where you give the viewer a hard checklist, a real proximity event, the kind that would make engineers go quiet, would likely leave a multi-sensor fingerprint, a sudden magnetic disturbance with a shape that repeats, a plasma wave change in the same window, a particle count anomaly, a brief systems irregularity like a voltage spike or timing glitch, all within a tight time window. And crucially, the pattern would not match known spacecraft cycles. That would not prove aliens. But it would prove Voyager encountered an unknown environment event that we do not yet have a clean explanation for. Now here is the best way to keep viewers locked for the long run. You don't promise a single answer. You promise a single reveal. You say the rest of this video is about one thing: finding out whether the hidden image is an artifact, a natural plasmoid geometry, or a genuine unknown signature that survives every kill test we can throw at it. And you make the stakes clear in plain words. If it's an artifact, the story is still interesting because it shows how easy it is to fool ourselves. If it's a natural plasma structure, the story is big because it means Uranus and interstellar space are more organized and stranger than we expected. If it's an unknown signature that survives all checks, then we have a new category problem, not alien confirmed. A new category problem, meaning our old labels like noise, random, and background are not good enough anymore. Now we're ready to zoom in. Next, we're going to reconstruct the Uranus window in a simple timeline, second by second, the way a mission team would. What Voyager was doing, what the magnetometer was reading, what the plasma environment looked like, what could cause a ring-like geometry during a plasmoid event, and why a perfectly timed systems hiccup in the same window makes people stop and stare. And after that, we're going to talk about the strangest part of all. Why a structured signature can feel like a footprint, not a message, a footprint. Because a message is meant for you. A footprint is just evidence that something was there. And if Voyager 2 captured a footprint, then the most unsettling possibility isn't that contact is coming. It's that contact may have already happened in silence, and we only just learned how to hear it. Voyager 2 is approaching Uranus, and everything about the encounter is a trade. You cannot slow down, you cannot orbit. You get one pass, and the spacecraft has to juggle pointing, data rates, instrument schedules, and the simple fact that it's trying to talk to Earth from very far away. Back on Earth, the Deep Space Network is the ear. NASA Jet Propulsion Laboratory is the brain that keeps the ear tuned. And the scientists are the people who will argue for months over 1 second of data if that 1 second refuses to behave. Now, Strip away the internet drama and focus on what can actually produce a ring-like signature near Uranus. Uranus has a magnetosphere that is tilted and offset. That means as Uranus rotates, its magnetic environment is not a stable, symmetric bubble. It wobbles, it breathes, it sweeps around like a crooked lighthouse beam. If you've ever tried to draw a perfect circle while your hand is shaking, you know the vibe. The circle becomes a shape that keeps changing even if the pen never leaves the paper. So Voyager 2 enters a region where the magnetic field lines are stretched into a tail. The magnetotail stores energy, and when that stored energy releases, it can form a plasmoid, basically a big organized blob of field and plasma that breaks loose and slides away down the tail. In that kind of event, you can see a signature that looks like a loop, a ring, a donut, a torus, depending on how you cross it and how you plot it. Not because somebody built it, but because magnetism and motion can draw clean geometry. Now here's where it gets uncomfortable. If the shape is clean enough, your brain will call it artificial, even if it's natural. So we don't trust the brain, we trust the checks. The first check is timing. If the hidden structure is real, it should lock to a specific time window. It should not smear across hours. It should not appear randomly on Tuesday and vanish on Wednesday. It should be tied to a defined segment of the flyby, the way a storm cell shows up on radar in a defined spot. So the team pulls the window. They look at what Voyager 2 was doing. Was it switching instrument modes? Was it changing pointing? Was there a known spacecraft activity that could make the sensors look weird? Was the transmitter power changing? Was the antenna moving? Because spacecraft do not just record space. Spacecraft also record themselves. Then comes the second check, shape persistence. If you plot the data one way and see a ring, and then plot it another way and the ring flips into a different ring, you might be looking at processing. But if you change the plotting method and the core geometry keeps its identity, even faintly, that is harder to dismiss. Now comes the third check, and this is the one that makes skeptics stop joking. Cross-instrument support. If the magnetometer sees a structured event at a certain moment, what do the plasma instruments see at that same moment? Do they show a change in density? Do they show a shift in wave activity? Do they show a boundary crossing? Do they show a disturbance that lines up? Because a real environment event does not politely touch one instrument and ignore the rest. A real event is messy, and it usually leaves fingerprints everywhere. Now, remember your summary. You mentioned a synchronized voltage irregularity. That detail can be used in a smart way if you treat it carefully. You don't call it proof of contact. You call it a coincidence that either strengthens the case or collapses under testing. Here's how. If the voltage irregularity happens during heavy spacecraft activity, like a mode change, then it's probably internal. If it happens during a calm period with no major spacecraft actions, and it lines up with a strong external disturbance, then it becomes interesting. Not because it means an object flew by, because it means the environment was strong enough or strange enough to affect both sensors and electronics behavior in the same slice of time. And yes, harsh space environments can do that. Charged particles can mess with electronics. Radiation can cause odd spikes. Magnetic environments can cause unexpected coupling. That's not aliens. That's physics with teeth. Now, if you want your viewers to feel the tension without losing credibility, you say something like this in plain language. If the pattern is just a processing trick, it will crumble when we recheck it. If it's a real Uranus magnetosphere structure, it will stay put like a scar in the data. And if it stays put, then the story is not about aliens. It's about how much of the universe we've been calling noise. Now, you asked for this to be hooking and to flow, so here's the part where the story tightens. Because Uranus is not the only place Voyager 2 saw something people didn't expect. Voyager 2 went on to Neptune, and Neptune's environment is also wild. Then it kept going into a region where the sun's influence gets thin, and eventually it crossed into interstellar space. That's where the rhythmic pulse part becomes the next pressure point. People love the phrase interstellar because it sounds like space is talking, but the better phrase is interstellar structure. Interstellar space is not a blank sheet. It's more like a dark ocean with currents, density changes, magnetic turbulence, shock fronts, ripples. We don't have a fleet mapping it in a grid. We have two elderly scouts, Voyager 1 and Voyager 2, each moving through a different path at a different time. So when Voyager 2 instruments detect plasma wave patterns that repeat, you have to ask one calm question. Is Voyager hearing a message? Or is Voyager hearing the shape of the ocean? Now, this is where you can bring in a few credible science references naturally, without turning it into a lecture. The plasma wave science for Voyager has long been associated with specialists who dedicate their lives to translating faint wave activity into real physical meaning. The team culture around that kind of work is brutally skeptical. They don't get excited because something sounds spooky. They get excited because something is measurable. And NASA Jet Propulsion Laboratory doesn't treat deep space like a haunted house. They treat it like a system with boundaries, with variability, with changes over time. So in your story, the real tension becomes this. If the interstellar wave pattern is truly coherent, then it says the medium out there has organized structures we still don't understand well. That alone is huge, because it would mean our random assumption is wrong. And if random is wrong out there, it changes how we plan future missions, how we interpret signals, and how we avoid fooling ourselves. Now, here is the practical test that keeps the story grounded and keeps viewers watching because it feels like detective work. Does the rhythm match known spacecraft cycles? If the pulse lines up with a temperature cycle, a power cycle, a routine instrument cycle, then the rhythm is likely coming from Voyager itself. But if the rhythm does not line up with known spacecraft behavior, then it leans external. Next test. Does the rhythm drift the way natural turbulence drifts, or does it hold timing with an odd stability? Natural processes can be stable, but they usually wander, they wobble, they smear. A pattern that stays too clean for too long becomes harder to wave away. Next test. Does the rhythm correlate with other sensors? If plasma wave activity changes while magnetic field activity remains flat, that can happen, but it weakens the single external cause story. If they move together in a physically meaningful way, that strengthens the case for a real environment structure. Now, let's address the AI stopped because of a cognitive hazard part in a way that sounds adult and believable. AI doesn't feel fear. It doesn't get spooked. It doesn't sense consciousness, but it can do one thing that makes humans feel uncomfortable. It can label something as a strong outlier, a segment so different from the background that it triggers a flag. And sometimes automated systems are designed to halt when they detect extreme anomalies, because pushing forward could produce garbage output. It's like a calculator saying error instead of giving you a wrong answer. So the truth is not the AI got scared. The truth is the anomaly was strong enough to trip the alarm. And that is still a powerful moment, because it tells the audience the weirdness is not just vibes. It is statistically unusual inside the dataset. Now comes the part where you keep people hooked without promising what you cannot prove. You shift from what it is to what it would imply. If the Uranus hidden structure is a real plasmoid signature, and modern tools simply revealed it more clearly, then we learn something important about Uranus and how space weather can reshape a magnetosphere in dramatic ways. If the interstellar pulse patterns are real environment structures, then the boundary region around the Heliopause is more layered, more active, and more organized than our simple mental picture suggests. And if both are true, then Voyager 2's legacy changes. Not from a probe that took photos of planets, to a probe that quietly recorded environments we still can't fully explain. That is already a great story. Now we move into the part that makes your title feel earned without screaming aliens. Because the word contact doesn't have to mean handshake. Contact can mean detection. Contact can mean influence. Contact can mean one system brushing another system and leaving a trace. So the next question becomes this. If Voyager 2 did pass through a structured electromagnetic event near Uranus, and if it later recorded structured wave behavior in interstellar space, is there a common thread? Is it simply that the universe makes more order than we expect? Or is Voyager 2's path unusually lucky, catching rare events that most probes never see? Or, and this is the edge of the cliff possibility, is there an unknown class of electromagnetic phenomenon that we don't have in our textbooks yet, that can look intentional even when it is not? Now here's the open loop we use to keep the audience glued. There is one type of evidence that would make this whole story hit harder. Not a pretty ring, not a spooky spiral, a time-locked multi-sensor fingerprint that repeats, meaning a specific pattern that appears in one era of the mission and then appears again later in a different environment with the same mathematical structure. If that happened, you could still avoid aliens, but you would be forced to admit something. Voyager 2 did not just witness random chaos. It witnessed a repeating signature. And if a repeating signature exists, then the real question stops being, what if we're not alone? The real question becomes, what else is hiding in data we already have? Because if Voyager 2 recorded one repeating signature, it might not be the only one. And the terrifying part is, we wouldn't even need to launch a new probe to find it. We would just need to look harder at what we already brought home. A message is aimed at you. A footprint is just proof that something moved through a place. If you're walking on a beach and you see a perfect boot print, you don't instantly know who made it. You don't know where they came from. You don't know why they were there. But you do know one thing. Something was here. Voyager 2 data, in the best version of this story, feels like that. Not a greeting card from the stars, a trace, a pattern that looks like it belongs to a real event. So here's the most convincing, physics-first reason a highly symmetric structure could show up during a Uranus plasmoid event, and why it could look artificial even when it isn't. Think of Uranus's magnetosphere like a spinning, crooked bubble being squeezed by a steady wind from the Sunday. When the solar wind pressure increases, that bubble compresses. When it relaxes, it expands. When magnetic energy builds up in the tail, it can snap and release in bursts. That release can form a plasmoid, which is basically a chunk of magnetic structure pinching off and moving down the tail. Now imagine a plasmoid, not as a messy blob, but as a rope, a magnetic flux rope. That phrase sounds complicated, but the picture is simple. It's like a twisted strand of magnetic field wrapped around itself, carrying plasma along for the ride. Those structures are known to produce clean, loop-like signatures in magnetometer data because the field rotates in a smooth, organized way as you pass through it. If Voyager 2 crosses one at the right angle, it can look like a clean ring signature in the data. Not because it's engineered, because your path through it was just right. That's like slicing a perfect onion ring. You don't need a chef in space. You just need the knife to hit the onion at the right depth. Now, add the part people forget. Voyager 2 didn't hover. It cut through the environment fast. That matters, because speed makes structure look crisp. If you walk slowly through a fog bank, you feel gradual change. If you sprint through layered fog, you feel sudden bands. You feel rhythm. You feel edges. Speed turns smooth gradients into sharp transitions. So a fast flyby through an organized magnetic structure can create signatures that look too neat, even though they're natural. Now, bring back your voltage irregularity detail, because this is where your story gets more interesting. If Voyager 2 flew through a region with a strong, rapidly changing magnetic field, it could trigger minor electrical quirks. Not a full failure, not a dramatic shutdown, just a brief hiccup, a spike, a weird little synchronized moment. This is not science fiction. Spacecraft electronics can be sensitive to charged particle environments and sudden changes in electromagnetic conditions. That's one reason spacecraft are designed with shielding and redundancy. And it's one reason engineers keep logs of odd behavior. So in your script, you frame it like this. The plasmoid event explains the geometry. The harsh environment explains the hiccup. And the combination explains why the moment feels like more than just noise. But we're not done. Because a good investigation doesn't stop at one nice explanation. We ask a harder question. If the structure is a flux rope or plasmoid signature, should we expect it to appear once or to appear as part of a family of events? Because magnetospheres don't do a thing once and never do it again. They repeat, they cycle, they have behaviors. So the next step is hunting for relatives. Other time windows in the Uranus flyby data where the magnetometer shows a similar rotation pattern. other parts of the magneto-tail crossing where plasma instruments show matching changes. If you find relatives, the weirdness becomes less alien blueprint and more Uranus has a kind of event we didn't catalog properly. That is still huge because it means we don't really know Uranus the way we think we do. And it also means we are leaning on a single flyby to define a whole planet's magnetic personality. That's like judging a person's whole life based on one awkward sentence they said in a crowded room. Now watch what happens when we slide the same logic into interstellar space. People say interstellar space should be random, but that's not a fact. That's a guess. Interstellar space has magnetic fields. It has turbulence. It has density structures. It has shock waves from solar activity and from larger scale events moving through the galaxy. So if Voyager 2 detects plasma wave activity that looks rhythmic, we don't treat it like a voice. We treat it like weather, interstellar weather. And just like Earth weather, interstellar weather can produce repeating patterns. If you've ever heard a distant thunderstorm, you know the weird feeling. You don't see the lightning clearly, but you hear repeating rumbles. Sometimes the timing feels almost regular. That does not mean someone is playing drums in the clouds. It means the storm has structure. Now here's the question that keeps your viewers hooked. What if the same kind of organized structure that makes a plasmoid signature look engineered near Uranus can also exist out in interstellar space, far away from any planet? Not the same exact event, but the same idea. A structured magnetic region, a flux rope-like formation, a layered boundary ripple, something that can make plasma wave data look like a repeating knock. Now, in a NASA-style story, you do not claim that is what it is. You present it as a serious possibility because it's the kind of possibility that is both grounded and unsettling. Grounded because physics can do it. Unsettling because it means the deep dark is not a calm, empty void. It means it has architecture, not built architecture, natural architecture, patterns that are real and measurable. And when humans see architecture, we instinctively wonder if there is an architect. That's the psychological trap. That's where channels go off the rails. So you keep the steering wheel tight. You say something like this in a calm voice. There are two ways a pattern can look intentional. One, it is intentional. Two, it is natural but rare. And our brains are not used to seeing it. And because our sample size is tiny, 2 spacecraft, 1 galaxy, we don't know how rare really is. Now, this is where you bring in your credible science references without turning it into a school lesson. You mentioned NASA's Jet Propulsion Laboratory as the mission operations brain keeping Voyager alive. You mentioned the Deep Space Network as the ear that makes any of this possible. You mentioned the Harvard-Smithsonian Center for Astrophysics as the kind of place where people specialize in interpreting weird signals and not embarrassing themselves. You mentioned the European Southern Observatory and the Keck Observatory in Hawaii as examples of how modern astronomy depends on cross-checking from multiple instruments, because one instrument can fool you. You mentioned the James Webb Space Telescope and the Hubble Space Telescope spectrographs as reminders that the best discoveries happen when multiple kinds of data agree. And you mentioned the old Ronald Bracewell probe concept from Stanford, not as proof, but as a historical example of how long scientists have wrestled with the idea that contact might be quiet, indirect, and easy to miss. You do all that naturally, like you're painting the setting, not like you're reading a list. Now, we take your ancient star map's angle and make it useful without turning it into a myth channel. Here's the clean way to do it. You say ancient sky stories are a record of human pattern recognition. People across cultures wrote down spirals, rings, eyes, serpents, and ladders in the sky because those are the shapes the human mind remembers. Sometimes that's just poetry. Sometimes it's an indirect memory of real sky phenomena, like comets, auroras, strange atmospheric lights, rare alignments. So when an anthropologist says the geometry in a modern space data set resembles old sky geometry, it's not a smoking gun, but it is a reminder of something important. We have always been trying to decode the sky, and we often describe it using the same symbols, because the sky keeps showing us the same kinds of shapes. And the universe keeps being bigger and stranger than our first explanations. Now, the story needs a new pressure point, something that makes the viewer feel like the investigation is getting closer to something solid. So you introduce the idea of a signature that repeats across environments. Not the same shape, but the same mathematical behavior. For example, a magnetic rotation pattern that has a specific symmetry, a plasma wave pattern that has a specific scaling behavior, a spiral-like structure that reappears under different conditions. If you find that, you have a real scientific mystery. Because then you are not just looking at one weird event. You are looking at a class of events, and if there is a class of events, then the question becomes urgent in a different way, not who is out there. But how many times have we recorded this without recognizing it? Because once you recognize it, you can start hunting for it everywhere. You can search Arecibo legacy data for similar structures, not because Arecibo was looking for aliens, but because it collected huge amounts of sky data that can be remined. You can compare with modern radio astronomy surveys. You can cross-check with magnetosphere studies from other planets. You can ask whether Jupiter and Saturn have similar signatures in their magnetotails. You can ask whether the Heliopause region can create similar coherence. And that is exactly how a deep space mystery becomes a serious science story instead of a clickbait rumor. Now, we're ready for a moment that feels like a turning page, without becoming a climax yet. Because the next step in the investigation is choosing one single thing to treat as the backbone. One anchor. If you try to chase everything, the story becomes mush. So you pick one anchor question and you keep returning to it. Here's a strong anchor that fits your title without lying. Did Voyager 2 record a time-locked, multi-sensor fingerprint during the Uranus encounter that cannot be explained by spacecraft behavior and cannot be fully explained by standard magnetosphere models? If yes, then Voyager 2 did not make contact in the movie sense. But Voyager 2 did brush against something unknown in the environment sense. And that is the kind of contact NASA actually cares about. Contact with a phenomenon, contact with a structure, contact with a boundary we don't understand. And if that happened at Uranus, it makes the interstellar patterns feel less like a separate creepy story and more like a continuation of one theme. The theme is this: the universe is full of structure we don't notice until we have the tools and the patience to look again. And Voyager 2, by accident and by stubborn survival, may be one of the best witnesses we've ever had. So if a mission team thinks they found something real but unusual in Voyager 2's archive, they don't come out and say, "We made contact." They use quieter words that mean more. They say anomaly. They say unexplained signature. They say, "We observed a structured feature." They say the data shows a pattern inconsistent with random noise. That last one is the key. Because it does not mean aliens. It simply means this: if you shuffle the data like a deck of cards, the pattern doesn't survive. If you leave the timing intact, the pattern stays. That is how you separate a coincidence from a fingerprint. And it sounds small, but it's huge. Because a real fingerprint creates responsibility. Once you say a pattern is real, now other people can test it. Now the Harvard-Smithsonian Center for Astrophysics people can poke it. Now space physicists who live and breathe magnetospheres can try to reproduce it with known models. Now radio astronomers can compare it to what we see in other data sets. Even old Arecibo legacy scans. Not because Arecibo was looking at Voyager, but because the sky has been recorded in so many ways that you can sometimes find echoes of the same kind of behavior. And that is why wording matters. If you call it contact too early, you lose the serious audience. If you call it nothing, you miss the moment. The right middle path is to treat it like a case file, a file with 3 sections. What we saw, what it might be, what it probably is not. So let's imagine the internal discussion, the kind that happens before anyone writes a public sentence. One engineer says, this could be instrument behavior. We need to check the housekeeping data. Housekeeping data is the boring stuff that saves you. Temperatures, voltages, currents, mode switches. Is the spacecraft okay numbers. If the hidden structure lines up with a known system cycle, you stop the drama right there. You don't need a cosmic visitor to explain a power hiccup. A plasma physicist says, the geometry could be a flux rope crossing. It fits with magnetotail dynamics. That person will start looking for relatives, other similar moments in the same flyby. If you can find 2 or 3 similar signatures, it becomes a class of events. That is how a mystery turns into science. A skeptical data person says, show me the same pattern with a completely different processing pipeline. Because that person knows the oldest trick in the world is to accidentally make your own discovery. If the pattern only appears when you treat the data in one very specific way, it's not a discovery yet, it's a question. And the lead on the room, the one who has to protect the mission's credibility, says something like this: we can talk about this publicly only if we can describe it in a way that doesn't force a conclusion. Because NASA doesn't do conclusions from one weird screenshot. NASA does tests. And this is where the story stays hooking without needing to peak yet, because the viewer gets to feel the tension of the tests. The tests are not exciting on paper, but they are exciting in reality because each one is a door. You open it, and either the mystery dies or it becomes harder to kill. Test 1. Does the pattern survive when you change the noise reduction settings? If it collapses, it was probably a processing ghost. If it stays, it moves up a level. Test 2. Does the pattern show up across different data channels in the same time window? If yes, it becomes more physical. Test 3. Does it line up with any known spacecraft behavior? If it matches a known cycle, it becomes less exotic. If it doesn't, it becomes more interesting. Test 4. Does it have the right kind of time shape? Real events tend to have a beginning, middle, and end. Artifacts tend to look smeared, or they appear and disappear for no physical reason. Now, while this is happening, you keep the viewer grounded with a simple reminder. Voyager 2 is an old spacecraft. It has quirks. It has limitations. It has noise, so the bar for calling something real has to be high. That's not a buzzkill. That's what makes the story scarier when it survives. Now let's bring in a detail that makes your narrative feel like a real newsroom report. The reason you can't just settle this with one new observation is distance. Voyager 2 is not near Uranus anymore. Uranus was a moment in history. You can't rewind space. You can't say, hey, can you pass Uranus again real quick? All you can do is squeeze the archive and compare it to everything else we know. So if there is a hidden structure in that Uranus window, it's like finding a strange reflection in a single frame of a security camera from 30 years ago. You don't get a second angle. You don't get a new shot. You only get analysis, which is exactly why modern tools feel so dramatic. Not because they create magic, but because they let you read old evidence with fresh eyes. And this is the perfect moment to widen the perspective just enough to keep the viewer breathing. Because the way science handles a possible anomaly is not unique to Voyager. When Hubble spectrographs see a weird line, it gets checked. When the James Webb Space Telescope sees an odd absorption feature, teams argue over calibration, noise models, and instrument behavior before anyone says the word discovery. When ESO runs a new analysis pipeline, they compare it to independent instruments. The same with Keck in Hawaii. The culture is cross-checking. Voyager is just harder because you only have one spacecraft, one pass, and one archive. Now, here's where you do something smart for engagement. You give the viewer a simple thought experiment that makes them lean forward. Imagine you're alone in a dark field at night. You're holding a cheap radio. Most of what you hear is static. But then, inside the static, you hear a repeating shape. Not a clear voice, not a sentence, a shape. You don't jump to, someone is talking to me. You first ask, is my radio broken? Then, is there a tower nearby? Then, is there interference? But if the shape stays, and it repeats, and it doesn't match any of your radio's usual behavior, you eventually have to admit something uncomfortable. There is something out there that is not random. That is the emotional core of this entire Voyager 2 story. Not aliens, not contact, not a handshake, just the uncomfortable idea that the universe may have structure we didn't expect, and our instruments may have been hearing it for years. Now we move the story into the one thing that will keep viewers watching for a long time. The pattern itself, because right now we've talked about tests and procedures and mission culture. That builds trust, but also creates hunger. So now you start describing what the pattern allegedly looks like in a way that is visual and simple. A ring-like structure, symmetry, a faint internal geometry that looks like layers or tracks. Not a perfect, clean neon ring, more like a ghost ring, The kind of thing you only see when you know where to look, and once you see it, you can't unsee it. And you put the viewer in the room with the data. You say the weirdest part is not that it's a ring. The weirdest part is that it appears in a window where other things look stressed too. A small electrical irregularity, a change in the surrounding environment readings, a moment where the space around Uranus behaves like it's doing something organized. And that brings us to the next natural question. If it's a footprint, what left it? A plasmoid event, a flux rope crossing, a boundary, ripple in Uranus's magnetotail, or something else entirely that we haven't given a name yet. And now we tighten the screws again by switching back to interstellar space. But we do it smoothly, because the reason the interstellar pulses matter is that they stop this from being a one-day Uranus mystery. They suggest a theme. That theme is structure hiding in what we call noise. So the next part of the story is about building a clean bridge. If the Uranus ring-like signature is real, what kind of physics creates that kind of organized geometry? And if interstellar plasma wave pulses show coherence, what kind of physics creates that kind of rhythm? And is it possible that both are simply different faces of the same big truth? That space is not quiet. It is not empty. It is not random. It is full of patterns that only look impossible until you learn the rules that make them. And that leads to the next investigation step. We stop asking, what is the pattern? And we start asking, what predictions does the pattern make? Because that is where a story stops being rumor and starts being a case. If it's a natural plasmoid signature, we should predict related events in the same flyby. If it's a processing artifact, we should predict it disappears under independent pipelines. If it's a structured environment feature, we should predict it correlates with other sensors in a physically sensible way. And if it's something truly unknown, we should predict it behaves like a footprint. It shows up, leaves a trace, and then it's gone. Not because it's hiding from us, because the universe does not care whether we notice. If the ring-like structure near Uranus is just a processing artifact, then it should behave like a mirage. It should be fragile. It should shift when you change settings. It should fade when you use a different cleanup method. It should look strong only when you treat it in one special way. That's the first prediction. Artifacts are picky. If the ring-like structure is a real magnetosphere event, like a flux rope or plasmoid signature, then it should behave like weather. It should have neighbors. It should have smaller versions. It should have related moments. It should show up as a family, not as a one-off miracle. That's the second prediction. Physics repeats. And if the ring-like structure is something truly unknown, something that doesn't fit cleanly into our models, then it should behave like a footprint. A footprint has a weird personality. It appears in one tight window. It is coherent. It touches multiple sensors. It does not care what you believe. And it leaves without leaving instructions. That's the third prediction. Footprints don't perform for the camera. Now let's take those predictions and walk them into the Uranus window like we're doing a proper review. You focus on one tight segment, not the whole flyby. Because the whole flyby is too big and you'll drown in noise. The weirdest things in big missions always live in small time windows. So you pick the window where the structure allegedly appears. You mark the timestamp. Then you pull 4 kinds of evidence from that same time slice: magnetic field behavior, plasma environment behavior, spacecraft housekeeping numbers, the voltages and temperatures and mode states, and geometry, what this spacecraft orientation was, where it was in relation to Uranus, and what region of the magnetotail it was crossing. If you can line those 4 up and tell a clean story, you have something. If you can't line them up, the pattern is probably lying to you. Now, an artifact will usually fail the housekeeping part, because if the spacecraft itself caused the weirdness, you'll often see it in the housekeeping numbers. A mode change, a power step, a temperature shift, a routine action, something boring but revealing. This is why engineers love housekeeping data. It's the truth serum. And this is also why viewers love it when you explain it simply, because it's relatable. If your phone camera shows a weird green line in one photo, you don't immediately say the sky is haunted. You wipe the lens. You restart the phone. You check if the sensor is damaged. You try another camera app. you test the boring stuff first. That's all we're doing here. Just at a scale where the lens is a spacecraft and the photo was taken near a planet we've barely visited. Now imagine the Uranus window passes the housekeeping check. No major spacecraft action. No obvious internal cycle. Nothing that screams, this is our own fault. Okay? That doesn't prove anything, but it raises the stakes. Now you look at the magnetometer. A real flux rope crossing often looks like a smooth rotation in the magnetic field direction. Not random jitter, a rotation, like a compass needle turning as you pass through a structured region. If the ring is real, you expect to see a meaningful rotation signature, not just noise. Then you check the plasma readings. If Voyager is crossing a plasmoid or boundary structure, the plasma environment should change too. Density, wave activity, particle behavior, something should respond. And if both the magnetometer and the plasma side move together in the same window, you're no longer just talking about a pretty shape. You're talking about an environment event. Now, bring back the voltage irregularity detail, but keep it disciplined. You don't treat it as proof. You treat it as a possible side effect. If the environment gets harsh enough, it can cause a tiny hiccup in electronics. It could also be coincidence. So the prediction is simple. If the voltage hiccup is meaningful, it should line up with the peak of the disturbance, not with a random, quiet moment. It should have timing, because real causes show timing. Now, if this all holds together, here's the clean sentence you can say in the script that feels strong without being foolish. Voyager 2 may have flown through a structured electromagnetic event near Uranus that left a coherent fingerprint across multiple measurements. That's already scary, because it means something big happened in that moment, and we only have one pass, one chance, one archive. Now we connect it to the interstellar pulse part of your story, because this is where viewers start feeling like it's one long thread, not two unrelated mysteries. The interstellar pulse claim has to pass the same discipline. If the pulses are a spacecraft cycle, they should line up with spacecraft routines. If the pulses are a natural plasma structure, they should correlate with physical changes in the environment. If the pulses are unknown, they should behave like footprints again. Time-locked, coherent, cross-sensor, and not matching any internal schedule. Now, here's where you make this feel like a real newsroom investigation. Because you give the viewer one simple trick that reporters use. You don't chase the most dramatic theory first. You chase the theory that explains the most with the least. So let's apply that. A natural explanation that covers both Uranus and interstellar space is this. Space is full of organized electromagnetic structures, and we're only now getting good enough at noticing them because we're mining the archive with better tools. That explanation is boring enough to be true, and it's still unsettling because it means our mental image of deep space as random static is too simple. Now, you can also add a second explanation that is still natural but feels more eerie. Voyager 2 might have been unusually lucky, meaning it passed through rare structures that don't show up often. It's like walking outside and seeing two rare lightning events in your life. That doesn't mean someone aimed them at you. It means you were there when the sky did something special. Now, there's a third explanation people love, the contact explanation. But if you're going to include it at all, you treat it as the last door, not the first door. You say something like this, calm and careful. Some people will ask whether a coherent pattern could be evidence of something artificial. There is no solid proof of that from Voyager 2 alone. But the reason the question keeps coming back is because the pattern looks too organized to dismiss easily, and because we have so little data out there that every rare event feels personal. That keeps your viewers engaged without turning you into a liar. Now, let's talk about what makes a pattern feel artificial in the first place. Because that's what your audience is really chewing on. There are two ingredients, symmetry and precision. Nature can do symmetry, but it often does it with mess. So when symmetry looks clean, people get suspicious. And precision, meaning timing and structure that doesn't drift much, can also feel suspicious. But nature can do precision too. A rotating system can pulse. A boundary can ripple. A wave can repeat. So the real question is not whether it looks designed. The real question is whether it behaves like a natural system or like a controlled system. Natural systems usually have variation. Even if they repeat, they wobble. Controlled systems often repeat with a tighter discipline. So one of your strongest hooks later in the video will be this. Does the pattern wobble like weather, or does it hold like a clock? Now, here's the part that makes your audience lean in, because it's the part that sounds like a spy story, but is actually just good science. If you suspect a signature is real, you don't only look at the strongest instance. You look for weak echoes, because a real phenomenon often appears faintly before it appears strongly, and faintly after, like ripples around a splash. So you would scan the Uranus flyby for smaller versions of the same rotation signature. You would scan nearby timestamps for partial ring geometry. You would look for subtle correlations with plasma data. And if you find even 2 or 3 weak echoes, the story changes. It becomes less like one spooky image and more like a repeating behavior. And repeating behaviors are where science lives. Now, you widen the frame just a little to show your viewers how this works across astronomy in general. When the James Webb Space Telescope sees an unusual feature in a spectrum, it gets checked against calibration. When Hubble spectrographs see a strange line, it gets checked against known instrument behavior. When ESO or Keck in Hawaii report something unexpected, it gets cross-checked with other observatories if possible. Voyager is harder because you can't point another Voyager at Uranus in 1986. But you can still use the same mindset, independent checks. Independent methods, same result. That's what makes a discovery, not the excitement. Now, there's something else in your summary that we need to handle carefully, but can still use to keep people hooked. The ancient star map similarity idea. Here's the clean way to keep it in without making it cringe. You say that people have always used rings, spirals, eyes, and serpents as symbols for the sky, because those shapes show up everywhere in nature and in observation. So when someone sees a ring-like geometry in modern data and thinks of ancient sky symbols, it may be coincidence. But it also shows something real about us. When we see pattern, we search memory. We try to name it. We try to fit it into a story. That's human, and it's exactly why scientists build kill tests. Because humans are good at stories and bad at restraint. Now, if you want this video to stay hooking for a full 2 hours, you need one main spine that everything hangs on. Here's a strong spine that fits your title, keeps suspense, and doesn't trap you into a fake claim. Voyager 2 recorded a structured signature in its data that may be natural, may be an artifact, or may be an unknown class of electromagnetic event. The job of this video is to walk through the evidence and see which explanation survives. That gives you room to be dramatic without being dishonest. Now we're ready to turn the screw one more time, because up to now, we've treated the pattern as an image. But the more serious way to treat it is as geometry in time. Not what it looks like in one frame, but how it evolves second by second. So here's what we do next in the story. We slow down. We walk through the Uranus window like it's security footage, moment by moment. What changes first? What changes next? What peaks? What fades? What stays stable? Because the order matters. If the magnetometer changes first and the plasma waves follow, that suggests one kind of structure. If the plasma waves spike first and the magnetometer follows, that suggests another kind. If the voltage hiccup lands right at the peak, that suggests the environment was harsh. If the voltage hiccup lands during a routine spacecraft action, that suggests internal cause. This is where the mystery becomes sharp instead of foggy. And it's also where the viewer starts feeling like they're watching an investigation unfold in real time, not a story being told after the fact. So let's take a breath and step into that Uranus window properly. Voyager 2 is in the tail region. The magnetic field is already not calm. It's not chaos, but it's alive. The numbers drift, then tighten, then start rotating in a way that looks almost too smooth. Then the plasma side begins to respond, like the environment is changing phase. And right around the moment where the structure is strongest, something small but noticeable happens in the spacecraft behavior logs. A tiny electrical ripple that is either the most boring coincidence ever or the kind of coincidence that makes engineers stare at each other for a long time. And that's where the case becomes dangerous. Because once you have timing, you can stop guessing. You can start testing. And if the timing holds, we're no longer asking whether the pattern is creepy. We're asking whether it's real. They run it through a second pipeline built by a different team with different assumptions. The shape is weaker in some settings, stronger in others, but it does not disappear. It stays anchored to the same time window, like it's nailed to the tape. They check the spacecraft housekeeping. No clean match to a routine system cycle. No obvious, we did this to ourselves moment. Not the kind that would explain a crisp, time-locked structure all by itself. They line up the magnetometer with the plasma measurements, and the weirdness stops looking like a single pretty artifact and starts looking like a coordinated event. The magnetic field rotates smoothly through a sequence that looks like a crossing, not a glitch. The plasma side responds in the same window, like the environment is shifting phase around the spacecraft. The timing is tight enough to make coincidence feel less comfortable. And then someone pulls the geometry. Where Voyager 2 was in relation to Uranus. What region of the magnetotail it was likely cutting through. How fast it was moving. What the solar wind conditions might have been like during that flyby. The best fit story, the boring story, the science story starts to form a spine. A structured magnetosphere event, a flux rope like crossing tied to a plasmoid release, a real piece of Uranus's magnetic world doing something organized and violent enough to carve a clean signature into the data. And if that's all it is, it's still a big deal, because it means our one close-up visit to Uranus may have caught the planet on a strange day, inside a magnetic storm we didn't know how to read at the time. It means the noise we ignored could have been the most valuable part. But then the conversation gets uncomfortable again. Because even after you explain the Uranus signature as magnetosphere physics, the interstellar pulses don't politely go away. Those rhythmic plasma wave patterns out beyond the heliopause still sit there like a second footprint in a different kind of sand. Not proof of a visitor, not a message, just structure, coherence. A suggestion that deep space isn't a blank sheet. It's a place with weather. The University of Iowa plasma wave specialists would call it a physical environment problem before anything else. JPL would call it an operations and interpretation problem. The Deep Space Network would call it a miracle that we can still hear anything at all. And the Harvard-Smithsonian crowd would call it what it is, a case built on timing, correlation, and the hard truth that we only have 2 old scouts out there to compare notes. So now the climax lands in a way that's both honest and unsettling. Voyager 2 didn't send back a clean photograph of a craft. It sent back something worse for our imagination. A structured fingerprint in the environment. A moment in the Uranus data that behaves like a real crossing, not like random snow. And a rhythm in the interstellar data that behaves like space, has layers we don't fully understand yet. And once you accept that, you can't unaccept it, because it changes the vibe of the whole mission. Voyager 2 stops being just a historic flyby machine. It becomes a witness that recorded things we did not have the tools or patience to interpret correctly the first time. Now here's the final twist, the one that hits harder the longer you sit with it. Even if none of this is artificial, the universe is still doing something that looks intentional to the human brain. It is building patterns in places we assumed were random. It is writing geometry into fields we assumed were just static. And it's doing it so quietly that you can miss it for decades, unless you know exactly how to listen. That's the humbling part. We keep asking if we're alone, as if alone is a simple yes or no. But Voyager 2 suggests a different kind of loneliness. Not empty loneliness. Ignorance, loneliness, the kind where you are surrounded by signals, structures, and behaviors you can't yet translate into meaning. And maybe that's the real reason this story grabs the throat. Because when the data is clean enough to be real but not clear enough to be understood, it forces a new question. Not who is out there, but how much have we been walking past without recognizing it? Think about it. We built this little machine in the 1970s, bolted a golden record to it like a message in a bottle, and shoved it into the dark. And the dark did what it always does. It didn't answer in words. It answered in physics, in patterns, in strange order hiding inside what looks like noise. So whether this turns out to be a rare Uranus magnetotail event plus structured interstellar weather, or whether it turns out to be something we don't have a name for yet, one thing is already true. Voyager 2 proved we're still beginners at reading the universe, and beginners miss things all the time. If you want the next part of this investigation, where we map the strongest fingerprint test that would separate natural structure from something truly abnormal, click the next video on your screen.